think you guys knows the rule. Still, you can enter this code, or you can scan this QR code for the Mentimeter, and you can see questions and you can enter the answers there, right? Okay, rules for the sessions. I think all of you knows the rules of the sessions now. But still, I'll be saying for solving each questions, we'll give 10 to 15 minutes according to the question and according to difficulty level. Uh, Google form, and you have to fill the Google form, and whatever you have done roughly rough work, you have to upload it on the Google form, right? And yeah, one of the toppers will be able to he'll chance to explain his answer. Okay, and then we'll discuss the stepwise solution for the problem. So today we'll be having only uh, this challenge session: the binomial, and one is general permutation and combination. So you have to submit your answers in the form http double dot double slash bit.ly dash challenge st capital S and capital T. Okay. Okay, this is the first question in your screen, and try to solve the question. So assume getting a red colored ball is equal for all trials. That means the binomial experiment. So I'm giving you the 10 minutes for this for this question to attempt. Yes. And so yeah.
Link for upload.
What happened?
Link for upload. So link is not opening for upload.
Link for the charging session is not opening. Okay. Okay, just a minute. I will show you the previous slide again. This link, can you try once? Okay, just let just give me a minute if it is not opening.
So could you paste that in the chat box?
Yeah, yeah, okay, okay. I'll paste it. Okay, fine. Okay, I have pasted the link. Okay, I think others are able to upload the forms because we got three responses. So yeah. So okay. So okay, till we'll I'll give 5 more minutes to solve the problem, right? So okay, until 2:30, 2:25 will I will give you the time for the solving because only three responses I have got. So I wanted more responses from you guys. Okay, uh, those who are having problem, are they able to upload the answer?
Yes, sir.
Okay, okay, fine, fine. Yeah. Yeah, hurry up, guys. So we'll be closing after 2 minutes. We'll stop taking responses.
Hello.
Yes.
Yeah, adding a picture is mandatory and it is taking time. Please wait.
Oh, it's again. It's taking time. Okay. So okay, I'll give you okay 2 3 minutes extra, right? Okay. For this problem, okay, until 2:30. Yeah, you can take the time, but it's not that tough. But okay, fine. We'll take the time for this question.
Can you post the Google Form link also, please, in the chat section?
I think I have shared already.
Yeah,
Okay,
but I
again
think
I'll share.
when I log in late, I think it disappears. Thanks.
Okay. Check it once. Yeah, I've shared it.
Got it.
Okay,
Thank
I
you.
will take. We'll close it at 2:28. Okay, fine. 4 minutes are there. Okay, one more minute, guys. Okay, now it's 2:28, so I'll stop taking responses. Okay, so okay. I think how I don't know how many of you got the answer. I'll check. So next thing is, okay, what do you think about the this first question? Just enter your responses here in Mentimeter. I'll check with. Yeah, fine. Okay, easy to. Okay, eight medium. Okay, fine. Fine. Okay. So about this question, the approach was important. How you approach this problem? It's not. Uh, okay, three of them are easy, eight medium, right? Okay. So we'll see how many of you got the correct answer. Um, so, five, six, seven, eight, nine. Okay, for around it's 6 to 7. I will announce the answer here. So the answer is 0.398 actually. So if somebody has given the 0.39 answer, that is also correct. Um, yeah. So I got around like not more responses, but yeah, some one, two, like around 10 to 12 responses I got, and around 5, 7, 8 people have got it correct. Okay, fine. So I will see who has given the correct answer, uh, like at earliest. Yeah. So around 9 people got it correct, but I will see who has got it right and first. So okay. Okay, anybody who has got this answer correct, they wanted to tell us about, or they wanted to explain about this problem. They can raise your hands, or they can write in the chat box. Yeah. Yes, somebody was talking. Yes, BK. Okay. If okay, Bimlesh, I think it's so. Bimlesh, if you want to explain the answer, you can go ahead. Please share
Yeah,
your
hi, good
screen and.
afternoon.
Yes, good afternoon. Yeah.
I won't be able to share my screen. I had already uploaded
Okay.
the approach. See,
Okay.
this is given like five different colors. Colored balls are there in the urn with equal proportions. So probability of finding
Yes.
each color ball is 0.2, and
Hmm.
this is a hypergeometric case. So expected value of any colored ball. So in this case,
Okay.
we are saying red colored ball. So
Okay.
expectation of finding. Suppose there are m number of balls of each color. So there are total
Hmm.
five number of balls in the urn. So expectation
Okay.
of finding the red colored ball is 15 into m divided by 5m, which comes out to be 3. So expected value
Okay.
is 3. Now we have this
Okay.
binomial experiment in which the probability of
Okay.
success is 0.2 and failure is
Okay.
zero point 0.8. So we have to find out the expected number of red balls which is less than expected. So basically px
Oh,
less than equal to 2. So calculating binomial experiment of n equal to 15 and p equal to 0.2
Good.
for x less than equal to 2 cases, it is coming at 0.398.
Yes, correct. Okay, so you have used this as hypergeometric parameter, right? Okay, right, correct
Correct.
only. Yes, correct. Okay, so I will go. I have approached in a different way. So I will share this screen to you and see. Okay.
Thank you.
Now, yeah, that is correct only. Yeah, thanks. Yeah. So, so we'll see the solution. So the answer is 0.398. So this is the step one. Because all five different colored balls are in equal proportion, we can say the probability of getting a red colored ball will be 1 by 5. That is 0.20, correct? So we'll be considering it as a probability of success p as 1 by 5 or zero point 0.2, right? So eventually it will be the probability of failure will be 1 minus p, which is zero point 0.8. So I think a lot of people have got, I think, that correct. So we'll see for the step 2. Step 2 says that the number of balls Pratik has received are equals to 15. That is number of balls Pratik, that is the number of trials, you can say. Yes. So n is equals to 15. And we know that this is a binomial experiment or binomial random variable. We know the value of expectation of a binomial random variable. It will be n into p, correct? So n into p, n here is 15 and p, that means probability of success is 1 by 5. So the expectation we'll be getting is 3, and we need to find out that how many number of balls are less than that expected value. That means number of red colored balls he will be receiving less than 3. That means it should take the value of 0, 1 or 2, correct? Now how many of you reached to this step? Maybe somebody has, like Bimlesh has approached in a different way, but it's correct only. Okay. Okay, I think, yeah. So these many guys. Okay, thanks. Okay, so we'll move to the step 3. So step 3 is, so it's just a addition of the probability of x equals to 2 plus probability of x equals to 1 and probability of x equal to 0, because we need to find out probability x less than 3. That is the number of red colored balls Pratik will receive um, than the expected value, right? So it's just a simple calculation by using the binomial distribution formula, nc2 p raised to ncr p raised to r into 1 minus p raised to n minus r. So by using that we'll be getting the value 0.398. Okay, so we'll move on to the next question. This is the next question. This is not from the binomial distribution. This is just a permutation combination question. So and this is not a very difficult question. So I will give you around let's say 5 minutes to attempt this question. And if you don't get any correct answers, we'll extend it to let's say 2 3 minutes more or 5 minutes more. Okay, fine. We then start solving this question. Who joined late? For them, this is the Mentimeter code for today's session, 8556750, or they can use this, uh, or they can scan this QR code. Okay, fine. Yeah.
Sir,
Yes.
So
Hello.
can we, it's triplet containing 2, 3, 4 means you need the triplet 2, 3, 4 or
Yeah,
1,
yeah,
2, 3 is
yeah,
enough?
yeah. No, no, no. The triplet containing 2, 3, 4. That means only 2, 3, 4. I needed 2, 3, 4, not 1, 2, 3, including 1, 2, 3.
So could you repeat? I'm sorry.
It should be only 2, 3, 4, not
Okay, sir.
containing 2, 3, 4. That doesn't mean 1, 2, 3. You need not to add one in there.
Thank you, sir.
Yeah.
The probability will be in terms of n only, no?
Yeah, yeah, probability in terms of n only. Yes.
So how to enter that?
You can enter n also. Like if some probability is, let's say, 5/n or something, you have to write 5 divided by n. Divide means like a slash. Use the slash. Okay. So
Sir,
yeah, yeah, yeah. Yes.
sir, selecting the triplet 2, 3, 4, meaning it is exactly selecting that triplet, right? Nothing else, right?
Yes. Yes. Yes.
Yeah.
Correct.
Yeah.
No, nothing else. Yes. So I think okay. I'll give two more minutes. Uh, okay. I think this is fairly easy question. I guess it's not that difficult.
Uploading. See, I need to transfer the photo and then upload. It takes time a little.
Yeah, fine. You can take time. It's nothing about it. Okay, we'll take 2 more minutes or 3 more minutes. Fine. See, lot of people, if you are getting correct answer, it's good only. It's just about, okay, 5 people who got it for correct, like fastest, will be the winners. But eventually, everybody should get the answer. Okay, so it's 2:44. So I'll stop taking responses, right? Or should I give some one more minute extra to upload if anybody wants to like have the answer?
No, sir. Let's do some more problem in the meantime, then, at least.
Yeah. Okay. Fine. Fine. So I'll stop taking responses. Okay. Fine. Right. Okay. So as per my reports, okay, six people got it correct. The answer for this question was 1/n-2. So I'm writing that answer in the chat box. Okay. Six people got it correct. Fine. Okay. Anybody who got this answer 1/n-2, they want to explain, they can.
Yeah, I can do that, sir.
Okay. Fine. Who's this? Can you
This is
tell?
Swaminathan.
Okay, fine, fine, something. Yeah. So yeah, can you share your screen of your screenshot or something
I
so
just
that
written Excel. Let's see. Yeah.
yeah, okay, fine. So yeah, yeah. In the meantime, others please uh, tell about their experience about the second question. Yeah, was it easy, difficult? Yeah, easy. Yes, it was easy actually. Yeah, it should not be more than six. Easy, because only six people got correct.
Sir, how do I share screen? I'm not able to.
Uh, okay, then I need to stop sharing my screen. Yeah.
Yeah, it's okay, sir. I think we can explain. This is not requiring too much calculation. Yeah.
I have stopped it. Okay, okay, fine. Fine. Otherwise, also, but if you share your screen, it will be like uh, everybody will get to know, right? Is it possible for you, or you don't want to share it?
No, no, sir, not able to. I'm just checking. There is some issue here.
Okay, fine, fine. Then okay, just tell us.
Yeah.
It's not needed.
Okay. There are there are n natural numbers. So
Okay.
triplet is very clearly given, right? It is three sets of three consecutive numbers, which means you
Yes,
can
correct.
select a triplet starting from 1, 2, 3 up to n minus 2 only. Because when you select the triplet from n minus 2, it will take n minus 2, n minus 1, and n, right? You cannot select any
Yes.
triplet
Okay.
starting from n minus 1 or n because you don't have three more numbers. So
Yes. Yes. Correct.
total number of possibilities is only n minus 2 triplets. Out of that, the question is
So,
asking about one very specific triplet, right? Which is 2, 3, 4. So
hmm,
it has to be 1 by n minus 2. Yeah.
correct. So the total number of ways of will be n-2, and there is only one way to select the containing 2, 3, 4. So that's why, yes, correct only. Thank you, Swaminathan. Yeah,
Thank you, sir.
Yeah, if the question
pronouncing it
if the
correctly.
question would have
Yeah.
been like if the question would have been
Uh,
to find the probability of
uh,
any
you,
triplet,
you,
any triplet.
your, your voice is,
Hello,
yeah. Yeah.
hello.
The question would have,
Is it clear now? If the question
yeah,
would
yeah.
have been to find a
Hmm.
triplet out of n natural numbers, any
To
I mean
find a
any
triplet.
triplet, not a particular 2, 3, 4 only, any triplet out of first n natural numbers, then would it have been
So
6
how
by
many
10
will,
to n minus 1?
no, 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 just a minute. If you are asking to select any triplet out of the n natural numbers, right? So there
Yes.
won't be any probability, right? Only how many number of ways you are selecting the triplets, or
No, no,
this
probability of
question just
selecting
tell
a
me about.
triplet out, I mean, finding the probability of selecting a triplet out of
Hmm.
n natural numbers. Then probability will be like the cases in which there will be a triplet and choosing upon choosing any three natural
No,
numbers, correct? Out of n. Hello.
but here the triplet means it's three consecutive numbers is already given, right?
Correct.
So if
So it's
asking
three
the question
consecutive numbers
like
and
that,
a
you are choosing
particular
three,
triplet
yeah,
it
yeah,
is asking, no?
yeah, yeah, okay.
So
Okay, yeah.
suppose two,
So
three,
if
four
you
is
are
not
asking,
mentioned,
okay,
and
I
any
understand your
triplet is supposed.
question. So if the hmm, hmm, hmm. So any
So in
triplet
that
that
case,
not
it will
triplet,
be, yeah,
any three numbers randomly chosen. You are saying any three random numbers are chosen, and you are asked
out
that
of which
what is the
how
probability that
many
finding,
find
then
that
it's
being a
correct. Okay, yeah,
triplet.
there will be the
So
case.
in that case, it
Yeah,
will
yeah,
be
yeah.
n minus 2 by
So but it
nc3.
will be uh, okay. Choosing three
And
numbers, yes, correct. In minus two, yeah, number of ways you can choose. Yes, correct only. Yes, yes.
okay, I
Correct only.
actually
Yeah,
read
that is
the
also a
question
good
in
question.
that.
Actually.
Actually, I understood the question
Okay,
in
fine.
that, so I gave the answer accordingly.
Right.
Thank you.
But that is also one another question you framed right now. Okay, that is also a
Acha,
good
acha.
question. Yes. Okay,
Okay.
fine. Thanks. Okay. So we'll see the solution again. Those who don't understand, I'll again explain it to them. So the answer for this question is 1 upon n minus 2. So in the step 1, the total number of ways of selecting a triplet from n natural numbers. See, we don't go for n natural number. Let's say we have 10 numbers only from 1 to 10. So the first triplet will be 1, 2, 3. Correct? The second triplet will be 2, 3, 4. And likewise, if you go until the until 1 to 10, the last triplet will be 8, 9, and 10. You can't select 9, 10, and 11 because we are restricted up to n. So only 8 triplets we can choose out of the 10 natural numbers, correct? So likewise, total number of ways of selecting a triplet from n natural numbers will be n minus 2, right? Because for 10 natural numbers you will be getting 8 triplets, that means 10 minus 2. So in case of in place of 10, we'll assume total n natural numbers. So the number of ways of selecting a triplet from n natural numbers will be n minus 2. And okay, how many of you reached this first step of calculating the number of ways of selecting a triplet out of n natural numbers? Yeah, they can send the responses, right? Okay, okay, almost okay. Five, yes, one almost. Then okay, six. Yeah, seven of okay. Okay, fine, fine. Okay, okay. So, okay, this is the step two. So, there is only one way of selecting a triplet which contains 2, 3, and 4. That's why the probability of selecting a triplet containing 2, 3, 4 will be 1 upon n minus 2. That is total number of ways of selecting triplets out of the n natural numbers, right? So, that was a easy question. I thought a lot of people will give the correct answer, but I think we got 6 correct answers for this question. Okay, no, no issues. So we'll move on to our third question. That will be our last question because you will be having the next session from 4 to 6, right? So after this third question, we'll end up this session so that we will get some time in between. Okay. So this is the third question for this challenge session. I'll give you 10 minutes to solve this question and let's see what will happen, right? Yeah, one more thing. This is the binomial theorem experiment, right? Yeah, this is the binomial distribution. I'm telling you. If somebody wants, don't confuse with another distribution. And one more thing, whatever answer you will be getting, round of it to the next integer, the next highest integer, higher integer. Okay? So we started this problem at 2:53. I will give you time until 3 or let's take 3:05. Okay, if anybody finds difficulty in like okay, so if anybody finds difficulty in understanding this question, just they can ask me. Means in English, I'm saying.
So could you please explain what does this 99.9%?
So basically, it should be the probability of selecting a person, or the probability of having a person among the randomly chosen sample,
Yes.
which will be having fever after taking a vaccine. That means if some person, you have chosen some sample, let's say 100 people you have selected. Among
Yes.
that, what is the probability that at least one person will get the fever after taking a vaccine? Okay, that means
Okay, sir.
100 people you have given the vaccine, and you should be finding the probability for that person who's getting, means at least finding a person, one person will be having fever after taking a vaccine.
Yes, sir. Thank you, sir.
Yeah.
Sir, what does this mean? How large a sample selected randomly would be needed? Like, what do we need to find out, sir, exactly?
Okay. So you need to find out the uh, number of people you have chosen randomly. Like how many number of people are there, so that this will, uh, if you have that many number of people, you'll get the probability of 99.9% of choosing at least one person.
Thank you,
Uh,
sir.
yeah, you got it right. I don't know.
Yes, sir.
Yeah, okay, fine. Thank you.
Please post menti.com code.
Okay, okay, fine. This is 8556750, or you can scan this QR code. Okay, 8556750. I'll put it into chat box also.
Uh, I don't know whether
Yes.
to tell you or not, but this week 10 assignments, they don't have submit button. I've already written.
Oh, is it week 10? You're saying, or week 11? Week 10. Hello, hello.
They have only check answer button. They don't have submit button.
Oh, okay, okay. I'll reach to our admin team and yeah, I'll ask them. I also don't know. For week 10, you're saying, right? Not for
Yes,
week 11.
I've written separately
Okay, okay,
also.
fine. Okay, okay, fine. Yeah, I will check. Thank you. Yeah. So it's 3-3. I don't think a lot of people have given correct answer. So are you finding it's little difficult to solve this question, or do you want more time, or is it enough? I think.
I think 1-2 minutes may be required. Someone has written.
Oh, okay. Okay. So do we need to use log? Yes. 1 minute. Okay. Fine. So I'll give you one more minute. It's already 3-4, right? It's fine. Okay, take one more minute. We'll close at 3-5. Yes. We have got 5 correct answers until now. So I'm extending
Eh,
one more minute. Yeah,
Is
yeah,
this a last question or one more question?
yeah. No, no, no. This will be the last question because you guys will be having one more session, right? Challenge session after
From
this, 4 to 6.
from 4 o'clock. Yes.
Yeah.
After that,
So,
CT is
so
also there.
okay. Then it's fine only. This is last question. I'm not going to extend it more. Anyway, it's binomial distribution is very this week is not that much of containing very wide variety of questions. It will be mostly similar kind of questions will be there. So yeah, okay. I'm stopping taking responses now. We'll get 5-6 correct answers. So please submit uh, your responses for this. What do you think about this third question? Easy, medium, hard, or something? Okay, okay, okay. Difficult, medium, right? Easy. Okay. Others also can please give your responses here about this third question, and then we'll move on to the solution. But before that, okay, I will announce the answer for that. The answer for that question will be 31. Okay, because I told you to round it to the next integer. So the answer for this is 31. The number of the number of people in a sample should be 31. Okay, I think yeah. Some guys find it difficult. Okay, 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 fine. So you want so anybody wants to hello? Yeah, anybody wants to explain the question from
Yeah,
who got this answer correct?
yeah, I can do
Yeah,
that, sir. I can share my screen also.
yeah. Thank you. Just wait a minute. I need to stop sharing. Then you can share. Yeah, now you can share your screen. Yes.
Can you see the screen? Yeah.
Yes. 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 Yes.
Okay. So thank you. So
Mhm.
it is given anyway. It is a binomial distribution. It is given that the probability of falling sick after taking vaccine is 0.2,
Right.
and the question talks about at least one person falling sick after the vaccine should be 99.9%. In other words,
Okay.
the probability of nobody should fall sick after taking the vaccine should be 1 minus 99.9%. That is equal to
Okay.
0.001. That means
Okay.
if there are n people, the probability of
Mhm.
0 people falling sick, okay, that is should be zero point zero
Yes.
zero.
Yes.
This is nothing but
Yeah.
the, so I apply the binomial, basically selecting 0
Mhm.
from 1. So the probability is nz0 star p power
Mhm.
0 star q power
Mhm.
n minus 0, which is n. So this
Okay.
value
Okay. Okay.
should be equal to
Should be equal to
0.001. Yeah. And the
yes.
nc0 is 1, we know that. P power 0 is 1. So the equation reduces to 0.8 to the power n equal to 0.001. If you solve it,
Yeah.
we
Okay.
get
Okay. Okay.
30.95.
For them, yeah. Yeah. For others to understand, this pointed comes from that q. Q raised to n. Q is nothing but the probability of not falling sick. 1 minus p. That is 1 minus point 0.2. That's why it's 0.8 raised to n. Yeah. Continue. Yes.
Yeah. Sorry, sir. I should have explained that.
Yeah.
So q
Yeah.
power
It's
n
fine.
equal to 0.001. Yeah. So if you solve this equation 0.8 to the power n equal to 0.001, you can take a log on both sides. So you will get n equal to
Yes.
log of 0.001 by log of 0.8, you get 30.95, but
Correct.
n has to be a round number. The nearest round number is 31.
Yeah, yeah, correct, correct. Thank you, thank you. What's your name?
Swaminathan, sir.
Samin. Okay, fine. Thank you, thank you.
Thank
Yes. So yeah, again, so we'll see the solution. Uh, so the step one is we know the probability of getting fever, that is probability of falling sick after taking a vaccine is given as 1 by 5, because 1 out of 5 persons will be getting fever after taking a vaccine. So the p, small p here
Can you
will
share
be
your
1,
screen, sir?
1 by 5. Okay, okay, sorry, sorry. Fine. I thought I shared my screen. So sorry. Okay, it's visible, right?
you. Yeah, yes, sir.
Hello. Yeah, so the step one is we are finding the probability of getting fever after taking a vaccine. That means we have given the probability of getting fever after taking a vaccine is p equals to 1 by 5. Small p is equals to 1 by 5, because 1 out of 5 persons are getting sick or are getting fever after taking a vaccine. So the probability of the 1 minus p will be, that is the probability of not getting fever after taking a vaccine will be zero point 0.8 or 4 by 5. Okay, this is our first step one. Then the step two will be, because we need to find out the n, that means the number of people who will be which we are randomly selecting will be we need to find out that that sample size for a probability of 99.9% that at least one person having a fever after taking a vaccine, that is a person will fall sick after taking a vaccine. What is the probability? At least one person will fall sick after taking a vaccine. We have given as 99.9%, that is probability of x greater than 1, that is at least one person will get sick, is 0.999. So this is our step 2. How many of you reached to this step? Please enter your responses. Okay, 4. Yeah, please enter your responses. Yeah, okay, 7. Okay, fine. Yeah, almost are 2. Okay, okay, that's it, right? So yeah, uh, so the next step will be the probability of x greater than or equal to 1. That means at least one person will fall sick. uh, that you can write in another way as no person will fall sick after taking a vaccine. Okay, so that means 1 minus probability of x equal to 0, which is given as 0.999. So probability of x equal to 0 is equals to 0.001, that is 1 minus 0.999, right? So probability of x equal to 0, that means probability of no person will get a fever after taking a vaccine. So we know this is the binomial random variable. So how we will calculate the probability of x equal to 0? So it will be nc0 p raised to 0 into 1 minus p raised to n, which is equals to 0.001. And we have calculated p and 1 minus p in a previous step. So our p was 1 by 5, or in other words 0.2, and 1 minus p as 1 minus 1 by 5, that is 4 by 5, or 0.8. But we know the value of nc0. Nc0 will be equals to 1, correct? P raised to 0 will also will be equals to 1. So 1 minus p raised to n, that is 0.8 raised to n, is equals to 0.001, right? And to find out n, we will be taking log on the both sides. So n log 0.8 is equals to, or in other words, log of 0.8 raised to n is equals to log of 0.001. So n will come that side. So n log of 0.8 equals to log of 0.001. So from there we'll find the value n is equals to 30.95, and the next integer to this n will be 31, right? So this is how we have to solve this question. Okay. So yeah, you can enter your responses for this. What do you think about this third question? And this is the last question of this session. Okay, easy, medium. Okay, 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 okay. Five people are saying easy. Okay, okay. Eight are medium, five are easy. Okay. Okay. So six are saying easy. So yeah, what do you think about this challenge session? Whatever you want to say, what are the your feedbacks you can write here. Okay, fine. Okay, guys. I think yeah. What do you want to write? You can write. Yes.
Sir, can we ask question from activity here? Just one question from.
The open session will be tomorrow morning, right? For statistics, you can ask there.
Okay, sir.
Uh,
Thank you, sir.
is it? Yeah, yeah. It's tomorrow. You can because there is another session, right? Yeah, tomorrow you can ask.
Okay, sir.
Okay, 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 fine, okay. So yeah, so we'll be closing this session. Yeah, it was good to talk to you, all of you. Have a good day.
Thank you, sir.
Yeah, thank you. Thank you.